When building a SaaS application, you need to take into considerations having multiple customers or tenant using your application. Today, I'm going to show you how to support multi-tenancy in your ASP.NET application by allowing multiple tenants using the same application. So let's jump into the code. I have here an ASP.NET application, an API application with EntityFramework, and 3 minimal APIs: get the list, get by ID, and adding a to-do item. If we run the application and we go to Postman, we'll get nothing. It's an empty array, and we can create. So let's create a task, do this, and it was created. We can now get that item. So to support multi-tenants, what I need to do is I need to make sure that we don't change any of our minimal APIs that we have here. I don't want to change any of the existing codes that I have. Instead, I need to make the client use the tenant name as part of the URL requested. So let's say client1/todo. I need to make sure that when calling an API, to pass by the tenant ID, the tenant name inside the URL as such. So to do that, let's start by creating a middleware. Tenancy middleware. And to implement the middleware, you need to do the following. So we need the request delegate, we need to initialize it from the constructor, and we need to create the invoke async method. So this middleware has the HTTP context. So basically any request that we are going to send, we are going to invoke this middleware. So we will have the request path, and we need to split it and get the tenant name from it. So we have var path equal .request.path. If path doesn't have any value, we should return 500 error. So context response .status code equal to 500 return. Make the method async here. So think about our URL as following. So the path is get client1/todo/1, getting the first to-do item for client1. So we need to split the path. So var segments equal path.value.split on \. Let's make sure that 1 dot per line is followed here. And we need to make sure that we exclude any empty string and we convert it back to an array. So our array segments should have at least 2 items, which is the tenant and the endpoint URL. So we can make a condition here, which is segments, if segments.length less than equal to 1, so if it is 1 or 0, we need also to return 500. So we can do something like this, status code equal to 500, and then we can actually write as JSON async, and we can return something like status equal tenant is missing, and like a message, tenant is missing from the request. And we return. So here we need to await and we can return. Now we know that our segments contain more than 2 items. We can do something like this. For tenant name equal segments 0. So by assumption, this is our rule. The first segment, the first item in the array, in the URL, is our tenant name. So we have the tenant name, and then we can await next with the context. So basically invoking the next middleware here. So to test that, let's go to the program.cs, and we need here to use our middleware. So what we can do is we go here, say app.use middleware, and we specify the middleware. So tenancy middleware. Make sure to add use routing because we need it to be after our tenancy middleware so we can get the URL. one thing that we forgot to do in our tenancy middleware is to change the URL, the path of our request. Basically, now when we inject the next one, our request contains the tenant, so there is no way our endpoints will be triggered. So it will contain the tenant. So we need to remove the tenant from the request path. To do that, let's change it by doing something like this. Context.request.path equal path.combine. Can combine a backslash with string.join backslash and segments.skip the first item, and then we can inject the next one. Now, going back to our program.cs, we can now test it out. By running the application, we can go back to Postman, and now client1/todo should return the array. But if we remove client1 and we only specify to-do, we are getting tenant ID is missing from the request. And if we remove everything, the same thing. So we are now having the tenant ID. We can now move to the next piece of the puzzle. So we need to make sure that our tenant provided from the request is a registered tenant in our system. So I'm going to create a new class here called Tenancy Manager. Let's also create an interface. Tenancy Manager, and we need to return a tenant, get tenant by the tenant name. So this is our method, and let's implement it in our class. So we don't have a tenant yet, so let's create a class called tenant. And for now, for our demo, we can have only two property, the ID and the title. So ID title for the tenant. And here, basically what you need to do here, we need a proper way to register a tenant, but for the sake of this demo, I'm going to make a switch case on the tenant name. So tenant name, switch, if it is client1, since we used that in our Postman, return a new tenant with ID equal to 1, title equal client1. In case we don't have a tenant, return null. Now, let's go back to our program.cs and register our tenancy manager so we can use it in our middleware. So builder.services.add scope, tenancy manager, tenancy manager. Now we have our interface that we can inject in our tenancy middleware. The nice thing about our middleware is we can inject our services inside the invoke async method. So we can do something like this, tenancy manager. Now, here we can do something like this, var tenant equal tenancy manager dot get tenant name. And now we can add another validation. If tenant is null, we can do something similar. Return 500, tenant is not registered. Tenant name is not registered. Okay. Now, let's do a quick run. Postman, client1, we should have a data, but if we specify something else, client5, we have tenant is not registered. So now our application do support multi-tenant. We need to segregate our data in the EntityFramework context. So going to the to-do item, we can add public and tenant ID. So we can have a tenant ID here, and let's go quickly to the database to add that column. So here, if we select our to-dos, we have this item that we created already. Now to add the column, we need to do something like this: alter table to-dos, add tenant ID int not null. If we run this command, it will fail because we already have a record in our database. So I'm going to remove that record, but in real life scenarios, you need to make sure that you have a default value here so you don't break your database. So add that default tenant, assign all the records to an existing tenant, and then you can fix your data later on. But for the sake of the demo, I'm going to delete all the records, delete to-dos, and then alter the table. So perfect. We have now a tenant ID here, and it is part of our model in EntityFramework. Now, basically, what you can do is you can start using the tenant ID everywhere to assign it, to use it, and to query on it. But we didn't actually use that tenant that we got from the tenancy manager. So I'm going to add few classes here with the tenant. I'm going to add multiple interfaces. So public interface iTenant that contain int ID get, string title get, and I'm going to add another interface, public interface iTenant setter with int ID set, string title set. We are going to use the iTenant setter interface to actually set our tenant instance in our tenancy middleware. So let's implement iTenant and iTenant setter. Okay. We can make it required so it stops nagging. Now, going back to the tenancy middleware, we can go here and inject our tenant setter, tenant. And now, let me change tenant here to current tenant. And here, we can set the tenant. So tenant.id equal current tenant.id, tenant.title equal current tenant.title. So we set the tenant from the tenancy manager value that we got from getTenant. And now let's go to the program.cs and register also our iTenant and iTenant setter. But I'm going to do something different here. I'm going to create an extension class, extensions, and make it static. I'm going to move tenancy manager registration from here to here. So public static iService collection add multi-tenancy. This iService collection services, return services, and let's paste this one here, fix it, and now we can add more stuff for our tenancy registration. So add scoped tenant. So we need to have an instance of tenant registered as scoped that we will use in our application. And then we need to register as well the iTenant. But we are not going to do it in the traditional way by specifying tenant here. We need to register it with the same existing registered instance for tenant. So we can do it by doing this as.get required services tenant, and same thing for iTenant setter. So what we are doing here, when using iTenant setter or iTenant, we are pointing to the same instance, which is tenant. Now, our tenant is working as expected. We can test it out by going to program. I'm going to create a new endpoint, map get tenant info, and we can inject iTenant, and we can return the tenant. Very simple endpoint. We can test it very quickly. Now, if we go to Postman, tenant info. Yes, we need to actually call our extension method. So builder.services.add multi-tenancy, something like this. So now if we run it back, run the endpoint, we got, removes. Client 5 is not registered. Let's add client 1. We got ID and title. Client 2, same thing. We get that second tenant. So basically now we can inject iTenant interface and use the tenant linked to this request. Now, the last piece of the puzzle is making sure that we don't change anything here in our endpoints and make sure the requests are multi-tenant. So go to the context. We need to override few methods here. So first one is on model creating. I'm going to use the hasQuery filter methods in the entity. So we make sure that tenant ID is set every time that we are requesting an entity from the database. Something like this. We need to make sure that we inject our tenant, private, read-only, iTenant, tenant. Let's initialize it from the constructor. And here we can use it. So every time we are requesting a to-do item, we will append a query, which is where tenant ID equal to the value that we received from the tenant. And another method that I'm going to override is save changes. So basically, when saving an entity to the database, I need to make sure that we set the tenant ID so we can make that link into the database. Something like this. For our change tracker, for to-do item, if the state is added, set the entity.tenant ID here. And then return the base save changes. Notice something that I'm using entries to-do item here and here because I only have one item here, but in your real life scenario, you will have like a base entity that contain the ID and the tenant ID. I showed that in a previous video, you can check it out. And then you can use that generic class to make sure that you set the tenant ID for it. So now let's run our application and test it out. So without changing anything in the endpoints, we can go to Postman and create a to-do. So if we run it, we will fail. We don't have a tenant, so let's add a tenant here. So client 1, eat a burger, send, we got it, and we got the tenant ID. And another one is drink a soda, send, we got another one. Let's change our tenant in the URL to client 2, and we can do something like eat, sleep, repeat, send. It's linked to the tenant 2, and now we can query to-dos. For client 2, we will get only one item, and for client 1, we'll get 2. Client 3 contains nothing. Perfect. And yeah, that's basically it. If you want to learn more, you can click on any of my videos here, and I will catch you in the next one. Bye.